So let's talk about this very important thing. Let's roll in. So my name is Stanislav, and people keep adding this to their presentations. So I worked 14 years in the industry. I don't know why this is relevant, but I mean, historically, in all of the conferences in Kyiv, people mention this somehow, some way. I don't know why. So I work as a DevOps consultant at our good company, Provectus. And the best thing about it is that you could be too. So if you want to just follow the links, well, you can see our guys, you can see our stand here. Just pay the visit, say hello, and well, maybe take some marketing stuff. So let's roll in. So we used to have monolithic applications. Now, these days, the typical application looks just somewhat like that. How do I use a laser pointer? Oh, okay. So this chart is called a character map. But this is not a character map for technology. This is a character map for literature. This is for Pride and Prejudice by Jane Austen. And I wanted to show that in the world of software, the services and microservices, interconnections, it looks very much similar. And services are actually living their own lives a bit like, in the literature. So you have generations of services. You had a legacy big monolith, and then you had its children, and it goes on and so forth, and then you buy another company, and it's a bit like marriage between two products, and they don't tend to get to converge fast in like a month or two. They tend to live for years and years and years, and they keep communicating with the APIs typically with one another. And because of all of these services and microservices, we have two additional questions for backend. They also were relevant back in the days of a big monolith, but now they are even much more relevant. So back in the days when you had like one PHP backend, and one database, it wasn't really a question, but these days we need to talk about service discovery. And service discovery is a very interesting and very hot topic. People talk about it a lot. So when you get to the infrastructure, to the architecture meetings, people keep speaking about it, and it starts like, oh, how do my service knows where the database is, or we're gonna use console, we're gonna use naming conventions, we're gonna use blah 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 blah. This is a very interesting topic, and it gets talked a lot. The other topic that is also very important is actually maybe even more important than service discovery, but it's not so hot. It's credentials. No one usually talks about credentials to the same extent, so it's not as fascinating, and that's actually a problem. So on the same architecture meetings, you see people talking about how they're gonna place all of these stuff like databases, Lambda functions, and then all of the accounts and tokens. They are either left as a final question somewhere at the end, or it's not even brought up. It's just they find one guy and you say, hey, John, you're gonna implement credential sharing. So how the login to typical application would actually work. So imagine you have application 1 and application 2. This could be like a backend and some kind of service API. It doesn't really matter. So first, there is a request like, well, give me the stuff, and the application says, well, who are you? And the other application would answer like, my name is Bob, and my password is Liberty. And the server goes to the database and asks for hash for password for user Bob. and get the answer, blah, 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 check if it matches, do the authorization part here, check if Bob is allowed to get the resource and provides the answer. Or at least I hope you do so in your applications. I just hope that parts of your applications don't authenticate just because they are in the same network, just because they have the network access. This is actually a very wrong and very bad idea. So yeah, it doesn't really matter what you provide here. So in this example, this is like a username and password. But more commonly, people use tokens, or people use client certificates. That's for systems, for machines, after all. That's not for like user from the internet logging in. But again, it doesn't matter. You need to have this, so the application one needs to know this thing in advance. So a new service starts up. Where to get credentials from? Well, a situation when a new service starts up is one of the most common situations that you have in your infrastructure today, because you have Lambda functions that are firing up and dying like in millions per second. You have your containers in ECS. You have EC2 instances that are they are constantly auto-scaling. They are constantly being scaled up, scaled down, so they constantly stop and start. And when they start up to work, where do they get all these credentials from? Where do they get this? My name is Bob and my password is Liberty. Well, you have options here. So the first and the worst option is you can just bake this all into the AMI, or bake it into your Docker image, or you can just hard code the stuff. So I've seen many Lambda functions that have credentials like a database credentials just hard coded. What's the problem? For anyone who worked just for a little bit, it's obvious what the problem is this is insecure. So your AMIs could somehow become public, and this wouldn't be even your fault. That someone from your team can do it. It's even much more easier for Docker images to somehow get public, because a random developer decided that it would be much more convenient for him to get to work with this at home, and so he publishes it to the Docker Hub, and and then it's public and you're doomed. And you can use hard code, but this is obvious anti-pattern. So never store your passwords, your secrets in the code, because you're gonna commit this to the GitHub, and then you're doomed. I don't even. I mean, it's even hard to count all of the cases when somebody, again, for some unknown reason, decided to make the repository public, or the source code leaked, and that's it. That's a problem. So the second option that more experienced people have is to provision everything with Chef, Puppet, Ansible, and just the script that runs over SSH. So, for example, you have the EC2 instance, you have a script that SSHs to it and provisions credentials. And this is actually a terrible way. I mean, all of this is terrible. This is terrible. So first of all, it reliably works just for the EC2 instances. It doesn't work. It doesn't really work for like containers, because SSH or just running Chef, Puppet, Ansible in the container inside is the anti-pattern. And then, well, connecting via the SSH to the Lambda function is not the option. So this way is kind of a little bit problematic. It's also problematic because it only works well when a new service starts up. It doesn't really super great when you need to change credentials that you are using right now, when you need to change your login to the database, for example. So let's move on. You can also get them from S3 bucket, so you can use the server-side encryption and so on and so forth. But hey, it was many times proven that S3 buckets sometimes can get to be public, and again, it's not your fault, it's somebody else on your team. So the typical recipe for this is you have one bucket that you start trashing with all of the things that you need from different teams, and you also keep certificates and logins and passwords there, and then someone on the team, maybe a newcomer, whatever, decides to just go ahead and open the bucket to be public because some kind of templates, blah, 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 need to be available publicly. And, well, the encryption will not help you. You might argue that you can use a client-side encryption. But again, if you use client-side encryption, it means that client has encryption keys. So a client needs to take those encryption keys from somewhere. You can also try to use parameter store. Parameter store is a AWS service, and this is actually the first good idea from the list. So it's not bad. But parameter store, it's secure, it's reliable. However, it's just a store. So it's a storage for secrets. It's not like, unlike the next point here, HashiCorp Vault. Vault is the credentials, full-scale credentials management system. It means it can also rotate your credentials. It can do all sorts of things. It can provide transparent encryptions, and all other services. So it's not only useful as storing your passwords, but it does a great job for this. And actually, if you are on the step 5, if you are on the Vault step in Amazon, it means that you are doing great. This is a great job. So I would highly recommend the system. It's nice. Now, there are surprisingly many more ways to do this. If you conduct technical interviews and just ask people the same questions, like how would you distribute your credentials, big chances are you're going to get yet another way at each technical interview. So this is very interesting. Now, I want to stress out this, that the question about credentials is the same for any code that you run on AWS, for EC2, for Lambda, for ECS. There should be an EKS, but I'll talk about it later. So this question is absolutely the same because credentials, they are not about surveys. Credentials, they are about code. So if your code runs, and as you know, actually, any useful program always has input and output. That's just a paramount. And these days, for your backend microservices, services, or Lambda functions, the typical output is not local. We don't really write to the files much these days. We use specialized services that then go and write to the files. We use things like databases and so on and so forth. So any piece of code has some result and needs to store it somewhere and needs credentials. So it's not just about things you run in EC2. It's much more. Now let's take a look about all those 3 options that we had on the list here. So let's take a deeper look on S3, parameter store, and Vault. And they all have something in common. In this scenario where you use them in AWS, they all have the common thing. So, and this common thing is actually the same question. How do you log in there in the first place? And the answer is very simple. We use IAM instance profiles, for example. So we use IAM roles. And this is great. This is exactly the recommended way of working inside the AWS cloud. If you have ever opened the best practices, Amazon asks you not to keep any of your AWS access keys in the code or bake them in somewhere. You should be using IAM instance profiles, and that's how you can authenticate in all of these 3 instances. Now, there is a caveat. So as you can see, two of those services are Amazon, the S3 and parameter store. So naturally, you should have no questions how they work because, well, IAM is also Amazon service, and obviously, they should be integrated somehow. But what about Vault? Vault is a third-party open source tool. It's done by HashiCorp and it's done by community. How it can go into IAM instance profiles and authenticate? Well, let's see. So all of this idea, it was inspired exactly by the way how Vault authenticates users in Amazon Cloud. And there is a very nice talk about it. It's called Deep Dive Vault AWS IAM Backend. So it's a very nice presentation. Please go and check it out. And there is another question. So you can use Vault, and you can use parameter store. But why would you do it if you just can go directly? If you can just use IAM, STS, and you would be able to authenticate your clients, your microservices in one another, and you don't need to have parameter store. You don't need to have credentials store. You don't need to have credentials even management thing. So how this would look like is that you just attach IAM instance profile. You would attach the IAM role to the instance, and the instance would be able to magically write into your API. And by the way, that API can reside not in Amazon, it can reside anywhere on the internet while there is a connectivity. So this is great. We would eliminate the need to distribute all of these tokens, usernames, and passwords. It's gonna just, infrastructure gonna just work. So let's talk a little bit about how all this works. This method is completely based on the notion that there is a who am I request on security token service. So this is like if you know, this is like AWS STS, security token service. This is service that we don't really know much about because all of its work is hidden from us inside the SDKs. We just know it's there. It's the primary service that gives you temporary credential that, for example, lets you work with Web Identity Federation and assume roles and so on and so forth. But there is a very, very, very good request, which is, well, we colloquially named Who Am I request, but it's actually in the documentation, it's called STS get caller identity. So whenever you send this request to the STS, STS doesn't give you any kind of token, but it authoritatively responds to you with the full information on who you are. What's your IAM role, and things like account ID, so who you are, and how this all is done. So it works on signed requests. So it's much easier to tell about it from the EC2 perspective. So in the EC2 perspective, you have the instance metadata, and you also have some information there that SDK is then used to sign cryptographically sign requests to the STS. So it's kind of secure. Also, those requests, they are short-lived. There should be an asterisk here. So they live for 15 minutes, but 15 minutes is actually just for the global STS endpoint. It could be different. The entire way was discussed/discovered here by the HashiCorp, by the Vault community, and then they have implemented here in this pull request. So knowing that we have this who am I request, what we're gonna do? We're gonna do the man-in-the-middle attack against the STS, but for the good intentions. It always starts from the good intentions, though. So let's see what we have here. So the application, your like client application, is gonna do all of the same. It's gonna ask, well, give me my stuff, and then your API, your second application, second microservice is gonna ask, well, who you are. And then instead of providing username and password, remember you don't have username and password, you have just started. So what you're gonna do, you're gonna use the Amazon SDK, and you're gonna sign the get caller identity request. But you would not send it anywhere. So you would just sign it. And then you get this signed request, which is cryptographically signed, and you would just forward it as is, without any changes, to your second microservice. And then this second microservice is gonna execute it actually against the STS. And the STS is gonna respond like, hey, here is your Amazon IRN, the IAM IRN. IRN is the Amazon resource name. It's for most here purposes, it's just a string, but it's a unique string that identifies IAM role. So that's all you're gonna need here. And what can you do right now? Well, right now you can have a mapping of the users and the IAM roles in your database, and you just look up the database. Do we have any user with this IAM IRN? And database says, well, yeah, well, sure, this is Bob. And so here you would do the uninteresting stuff. So you would authorize the user, like decide if the user can do this and this, and so on and so forth. And then ideally, well, in this example, it's going to issue a token that this application could use like casually. So usually it's like a short-lived token. So you would utilize this get caller identity thing just to authenticate. However, you can use it casually, and there is no problem with that. For example, if you're using Lambda functions are stateless. They don't have place to store the this authorization token. So you would just forward your request that you need from your API alongside with this request, and the API would know that this request came from your Lambda function because it took the part with STS caller identity and executed and did all the stuff. So let's move on. I have an example implementation. It's on GitHub. So the API server is a very simple Ruby on Rails application, and I'm quite sure you guys absolutely love Ruby on Rails. If you don't, please do. The client is a Python script, and you would need 2 instances. Again, actually, you only need 1 instance for the client, and it has to have instance profile. The server could be anywhere, but just for the demo part. So what client is doing, it generates the get caller identity request. Again, it then sends it to server to /authenticate. So the 3000 is the default port for Ruby on Rails. You're gonna love it, so please learn Ruby on Rails. Then it gets the GVT auth token back from the application, and then it can use the GVT auth token to do stuff. GVT is a JSON web token. It's a very simple thing. So here is the main part of the code here. And it's nothing secret. So we use the BotaCore library. We create, construct the client, choose the endpoint. I'll talk about endpoints later. We choose that we want to send get caller identity, blah blah blah. And what's interesting here is that we can add our own custom headers to the signed request itself, and those headers would also be signed cryptographically. So why this is important? This is important not for the general security from the outside world. It's important just for you. So the client generates a request that is intended to a particular server. So this APP ID is actually a server identifier. So this is important for you just because you don't want to accidentally send requests that were generated, say, on a development environment into production server. So how Vault guys are doing this, they have server hostname here. And then nothing special, you just encode it as base 64 and send out. So works very easy, provide application ID, provide URL, get your token. You can use this token with CURL. Very, very simple. So what server is doing? Server is the basic Ruby on Rails application generated with ---- API. It has the gem GVT, gem simple command, because it was easy to use. So it receives login and authenticates. Then it sends signed request to STS. Again, asterisk here, we'll talk about later. If the role is found, it looks for the user, generates token. So the most interesting part, the most important part is here. So the client sends a request for the particular endpoint. There are many endpoints for the STS, the global one and the regional endpoints in each region. You can also have the endpoint in the VPC, and the only client actually knows for which endpoint it signed the request. And this endpoint is forwarded also by the client. But you should never trust the client and blindly execute requests to where it asks you to execute. So, for the sake of demo, this is hard coded here. But in the real world, like in Vault in a Vault server, what they do, they have this as a configuration option. You can also have the whitelist and then check whatever thing clients send you against the whitelist. And so nothing really interesting. You just build the request. Again, the request method comes from the client. You build the request. You take all the headers. You check that this header was intended for you. Again, this is hard-coded here, but it should be a configuration option. Just an example. And then you get the response if it's 200 and body is not empty, and you play with XML. And so the ARN that comes from STS, it's in STS form, but it's very easily translatable into IAM one. And that's it. So that's how it all works. I have the big README file in the application itself, so it's very easy to install. When you install it, you just need to create one client. And, well, yeah, that's exactly how IAM role is looking. Looks. So that's a slide with an example of the signed request without base 64 encoding. So you have the request headers. The token comes here. It's very big, very large. So I had to strip it here. As you can see, nothing superficial. So we come to the Q&A session, and I wanted to say a few words. I just don't have the summary page, so before we just jump to the Q&A, by this talk, I wanted to encourage people who create applications, people who do service third-party applications that we are using then in our world, in our infrastructure. I wanted to encourage them to try to utilize this way. Imagine a world where, for example, MySQL database could authenticate users just based on the IAM instance profiles. That would be great. I mean, that would be super good for things like Lambda functions writing into the database. It would be also super great for things like Postgres and so on and so forth. The other question that I told in the beginning that I'm going to address is the EKS, Elastic Kubernetes Service. So currently, right now, you cannot assign IAM roles to Kubernetes pods. But this issue is on the roadmap, and it's going to be implemented someday. Luckily, when you work inside of the Kubernetes cluster, you have just plenty of other options to authenticate. So the issue is not as it's not as hard for you. That's it. Please, questions. No one writes applications. No one writes backends. Come on, guys, it's a backends and infrastructure.
Okay, let's imagine you've got the session manager, okay? Every user connected and type sudo -s, got the root privileges. Are there any native AWS tools to manage it?
Oh, you mean what to do if different users at the same instance, at the same host?
Yep, just using session manager, you type sudo s.
Well, you don't. I mean, how would you
using the
right? Well, you can't. I mean, this is exactly the same as imagine. So you have the EC2 instance that can write to the S3 bucket using the IAM roles. This is exactly the same notion. And I do agree that it might be, for the EC2 instances, it might be unhandy if you want to have a lot of users because typically it's just a Linux box. It can have different applications with different privileges. But imagine you're running an ECS task or Lambda functions. You would never have, ideally, you would never have this problem here. And also, people live happily with IAM instance profiles and accessing Amazon resources, and they, typically don't suffer from all of the things that you described, like different users, different level of permissions, and so on, blah, blah, blah.
Okay, thanks.
Hi. My question is a little bit maybe off topic because we were talking about service-to-service authorization.
Yes.
Yeah, but my question is about integrating the Cognito with IAM. For example, if we have some mass product where users are registering and so on, but we want them to have their own proprietary stuff, for example, in S3, and we want them to map, and we don't want to have the like an S3 bucket.
This is a great question, and I would say that yes, it's gonna work. It's gonna work correctly because when we sign this get caller identity request, we do this with the temporary credentials that we have received previously. Amazon SDK is doing this for us on the background somehow. So as long as you have temporary credentials, it's gonna work like 100% for sure. So yeah, I mean, you could theoretically use it this way also. Anyone? Questions?
Hello, and actually I can't understand why it is easier to sign clients' request with these temporary credentials and send to our backend APIs instead of just using API gateway with AMIs to roles and.
Well, you can, but I mean, look, this way also works. For example, you can create your authentication backend in MySQL database. And I hope that, for example, Mykola works in Percona, and they have a lot of stuff for databases like MySQL. And so MySQL database, you would not use the API gateway for this. I mean, I did the API as an example that this schema works. But potentially, you can use anything, any application that requires authentication. So in a broad terms.
Okay.
So the API was just an example because it was easy to do. Because for a DevOps guy, it's much easier to have the Ruby on Rails API dropped in the 10 minutes and so on and so forth. But again, so the previous question was about, can you use it when you utilizing the Web Identity Federation, for example? And yeah, it's going to work also.
Okay, thank you.
Questions? No? That's it then. Let's go drinking coffee.